Alright, so today we're going to start section 10.3, which is solving trig equations. So our objective is to use the trig identities and some algebra to solve trigonometric equations. This is where we're also going to have to understand the verifying and the simplifying that we did in the previous two sections. Okay, so first solving a basic equation. Hopefully we can all solve the equation 2x plus 1. We subtract 1 from both sides. Then we have 2x equals negative 1. Divide by 2. And we end up with x equals negative 1/2. Okay, now when we solve a trig equation, we follow the same exact steps. So we're going to subtract 1 and divide by 2. So I end up with sine of x equals negative 1/2. But this is what sine of x equals. This is not what x equals. We need to figure out what x equals. Now for the first one here, I gave us a restricted domain. I said we're limiting it to between 0 and 2 pi, including the 0, not including the 2 pi. So we need to think on our unit circle, where does sine equal negative 1/2? Well, sine equals negative 1/2 when x is 7 pi 6th and when x is 11 pi 6th. So that is the extra step that we've added now. So when we solved just an algebraic equation up here, we just get our x right away. When we solve a trigonometric equation, we get the sine of x. Then we have to use our unit circle to actually evaluate x. All right, this top example, I had a restricted domain of 0 to 2 pi. What if I don't put that down? Well, we still know that if I do my algebra, subtract 1, divide by 2, sine of x equals negative 1/2. And we know that on the unit circle, that's going to be at 7 pi 6 and 11 pi 6 between 0 and 2 pi. But I want to cover every single value where sine of x equals negative 1/2. Think about the graph of sine of x. It goes from negative infinity to infinity with its domain. So there's an infinite amount of values where sine of x equals negative 1/2. How do I write all of those values? Well, we're going to write them as x equals 7 pi 6 plus 2 pi n, where n is any integer. And so this represents every single coterminal angle of 7 pi 6. At every one of those coterminal angles, sine is going to equal negative 1/2. Then we'll also do this for the 11 pi 6. So if we don't have a restricted domain, then we're going to have to write general terms to cover all of the coterminal angles, where in this case, sine of x is going to equal negative 1/2. All right, so now here we want to solve 3 cotangent squared of x minus 1 equals 0. For part A, solve between 0 and 2 pi. For part B, we want the general solution. So first do our algebra, add 1, divide by 3. Cotangent squared of x equals 1/3. Take the square root of both sides. Cotangent of x equals plus or minus root 3 over 3. So now for part A, we have to think, okay, between 0 and 2 pi, not including 2 pi, but including 0, where does cotangent equal plus or minus root 3 over 3? And that's going to be at all of the pi 3rd angles. So these are our answers for part A. Now for part B, how do we turn that into a general solution? So for B, now the nice thing is I don't have to do it actually for each one of these, because pi 3rds and 4 pi 3rds have a relationship. They are pi apart. So I can just write x equals pi 3rds plus pi n. And then I can also write x equals 2 pi 3rds and 5 pi 3rds are also pi apart. So 2 pi 3rds plus pi n. So this is my general solution now. And that's something you want to pay attention to when you're trying to do the general solution. Is there a nicer relationship between the angles that you found for the explicit solution between 0 and 2 pi. If there's a shorter relationship, then we can use that. So in this case, there's a relationship of just pi. Okay, now I'm going to have you do a bunch of examples. So next one here, I want you to try and solve between 0 and 2 pi, secant squared x minus 1 equals 0, find a general solution as well. Pause the video, do that, unpause when you're ready to check your work. Okay, here, so first we solve for secant, so we add the 1, take the square root of 1, we're going to end up with plus or minus 1. So on the unit circle, where does the secant values equal positive 1 or negative 1? Well, secant is the reciprocal of the x value equals 1 when the angle is 0, and it equals negative 1 when the angle is pi. So for part A, we get 0 and pi. For part B, again, these are nice, they have a relationship, they are pi apart, so we could write x equals 0 plus pi n, or you don't have to write the 0, because remember, n represents any integer, 0 is an integer itself, so if I just say x equals pi n, that is correct as well. Either one of these would be correct on a test or a quiz. Okay, next one, I want you to solve sine squared x equals 3 cosine squared of x. You will have to use identities here to get this in terms of a single trig function. That's your hint. So find the explicit solution between 0 and 2 pi, find the general solution, pause the video, unpause it when you're ready to check your work. Okay, so here I showed two different methods to get the same exact solution. So over here on the left, what I chose to do was divide both sides by cosine squared x. So then I know sine squared x over cosine squared x becomes tangent squared x, and on the left-hand side the cosines cancel, and I'm left with just 3. Take the square root of both sides, I get tangent of x equals plus or minus root 3. On my unit circle, where does tangent equal plus or minus root 3? It's at pi thirds, 2 pi thirds, 4 pi thirds, and 5 pi thirds. Over here on the right, what I chose to do was substitute for cosine squared of x. I could have also substituted for the sine squared of x. I just chose cosine squared just for the example. Cosine squared is 1 minus sine squared of x. Distribute the 3, I get 3 minus 3 sine squared of x. Add 3 sine squared of x to both sides, I get 4 sine squared of x equals 3. Divide by 4, sine squared of x equals 3/4. Take the square root, sine of x equals plus or minus root 3 over 2. Where does sine equal plus or minus root 3 over 2? It's the same answers, pi thirds, 2 pi thirds, 4 pi thirds, and 5 pi thirds. Then our general solution, x equals pi thirds plus pi n, and x equals 2 pi thirds plus pi n. Next one. Here, find the explicit and the general solution. 2 sine squared x equals 2 plus cosine x. Again, you're going to have to use a substitution or your identities. Here, you have less choices though. So try this on your own, pause the video, unpause it when you're ready to check your work or if you get stuck. All right, so here, what I recognize is I have a sine and a cosine, but I can't change a cosine into a sine. I can change a sine squared into a cosine squared, though, using my Pythagorean identity. So now here I know I have to change the sine squared, so I substitute in 1 minus cosine squared. Then I distribute the 2, I end up with 2 minus 2 cosine squared x equals 2 plus cosine x. If I subtract 2 from both sides, those cancel. Bring everything over to one side. I could have brought it over to the other side. It doesn't matter. And then I'm going to factor out a cosine. In this case, I chose to factor out the negative cosine. Again, that doesn't make a difference, or it won't in the end. So now that I have negative cosine of x times the quantity, 2 cosine of x plus 1 equals 0. Set each factor equal to 0. I get cosine of x equals 0. Cosine of x equals negative 1/2. So on the unit circle, where does cosine of x equals 0? Cosine of x equals 0 at pi halves and 3 pi halves. Cosine of x equals negative 1/2 at 2 pi thirds and 4 pi thirds. So that is my answer to part A. Those are all of my solutions between 0 and 2 pi. For my general solutions, for the first ones here, pi halves and 3 pi halves, those are pi apart. So I can do x equals pi halves plus pi n. 2 pi thirds and 4 pi thirds don't share anything common. They're 2 pi thirds apart, but I can't continue to add 2 pi thirds because then I'll end up at pi thirds, and that doesn't work out. So I have to do each one of these separately. X equals 2 pi thirds plus 2 pi n, and x equals 4 pi thirds plus 2 pi n. Next one. Solve 2 sine squared x plus 3 sine x plus 1 equals 0. Pause, unpause when you're ready to check your work. Okay, so here what we want to do first is recognize that this is of quadratic form. So think about the quadratic. If you have 2x squared plus 3x plus 1 equals 0, how does that factor? So that's what we're going to do here. This factors into 2x plus 1 times x plus 1. So here I'm going to factor this into 2 sine of x plus 1 times sine of x plus 1. Set each factor equal to 0 then. Solve for sine of x, and I end up with sine of x equals -1/2 and sine of x equals -1. Sine of x equals -1/2 when x is 7 pi 6 and 11 pi 6. Sine of x equals -1 when x is 3 pi halves. Those are my explicit solutions between 0 and 2 pi. My general solution now is going to be x equals 7 pi 6 plus 2 pi n, x equals 11 pi 6 plus 2 pi n, x equals 3 pi halves plus 2 pi n. All right, last one. So now here you're going to have to use some identities again. Since we have a cosine, a sine, and a tangent, we need to get this in terms of hopefully one trig function. It doesn't always have to work out that way, but that makes things easier. So try to find the solutions between 0 and 2 pi. Try to find the general solution. Pause the video right now. Unpause it when you're ready to check your work. Okay, so what I did first here was I changed tangent into sine over cosine. The reason why I did that was, right, again, at the beginning I have cosine, sine, and tangent. Well, at least I know if I change tangent, I can eliminate one of those trig functions and then just work in terms of sine and cosine. When I did that, I recognized that I have a least common denominator of cosine. So then I multiplied the entire equation by cosine, so both sides, but just in the numerator. So it gets rid of the denominator here, but when I distribute cosine times cosine becomes cosine squared. When I distribute here, again, the cosines cancel, and I'm left with sine times sine, which is sine squared. And then on the right-hand side, I have 2 cosine of x. This is not the only way to do this. You could have gotten a common denominator on the left-hand side, combine like terms. There are many other things you could have done. This is just one method. Cosine squared plus sine squared, well, we know this equals 1, so I'm left with 1 equals 2 cosine of x. Now from here I have a choice. Over here on the left, I divided both sides by cosine, so I ended up with 1 over cosine equals 2, so secant of x equals 2. Or I could divide both sides by 2, and I end up with 1 over 2 equals cosine. Either way, I'm looking at my unit circle. Secant of x equals 2 at pi thirds and 5 pi thirds, or cosine of x equals 1/2 at pi thirds and 5 pi thirds. Those are my explicit solutions. My general solutions then are going to be x equals pi thirds plus 2 pi n, x equals 5 pi thirds plus 2 pi n. One thing I want to be cautious about with the method that I chose here in the beginning, when I multiplied everything by cosine of x, the denominator went away. I have to be careful that that doesn't lose a possible solution. Here in this case it didn't, because I still ended up with cosine on the right-hand side and I still had a cosine on the left-hand side, so I didn't cancel anything or lose any solution there. But that is something you have to be cautious about when you're multiplying both sides of the equation by something to get rid of a denominator. So our strategies here then, in general, when we're trying to solve trig equations, isolate the trig functions on one side of the equation. A lot of times that's going to help you out. Use algebra, factor, multiply, combine like terms to simplify the equation. Use your trig identities to convert to one type of trig function. You're not always going to be able to convert to one type of trig function, but you want to try to do that, or if you can't, then you want to be able to factor something. These are our strategies.